Okay. Does anybody recognize this formula before we get started? Have you seen this before? This is something called the difference quotient. Does that ring a bell now that I say it? Difference quotient? Some of you yes, some of you no? Okay. So, basically what it does is it's a formula to find the slope of a secant line between 2 points on a curve. So, what I mean is, let's say I had some function and it looked like that, right? And I wanted to find the slope of the line between those 2 points. What I can do is use the difference quotient and then plug in my values, and it would tell me what the slope of that line is. Okay? You'll do a lot more with this in calculus. So, this is just sort of a little preview some of the things that we're doing with function composition here, okay? So when you think about what this thing looks like, if you graph that, what's it look like? This. It's a what? It's a straight line, right? It's a straight line. So it's not, I mean, it's a curve, but it's a straight line, you know what I'm saying? So if I were to find the slope of it, well, doesn't it just make sense that it would just be the slope of that line? Yeah, so when you actually did the difference quotient, if you took x plus h and plugged it in the function in place of x, and then you subtracted from that, whatever you got, the entire function, and then divided the whole thing by h, was anybody able to do that and come up with an answer? What'd you get? Yes, it actually just simplifies to be -3. So, if we kind of take a look, let's zoom out a little bit. So, guys, remember how evaluating functions works. Whatever is in this parenthesis, you're going to take that whatever it is, okay, no matter what it looks like, whatever it is. And I'm going to go to my function, and wherever I see an x, I'm going to replace it with whatever was in there. Okay, so that was my first chunk to do this piece. I found f of x plus h. So, there's f of x plus h. I did -3. And then instead of writing x, I wrote x plus h, because that was what was in the parentheses. And then I have a -4. When I simplify that chunk, this is what I get, 3x minus h minus 4. So then if I continue with the formula, so I have this chunk, now I need to minus f of x from it. So that means I'm just going to subtract the original function. Make sure though, guys, that when you subtract, you have to subtract the whole thing. So it's now going to need minus -3x and minus -4. So what happens when you minus negatives? They turn into pluses, don't they? So that's how I got a plus 3x and then a plus 4. And still continuing with my formula, now I'm going to take that whole thing divided by h. So I put that whole thing over h. And then, if you look closely, you'll see that a whole bunch of them cancel out. I have a -3x and a positive 3x, a -4 and a positive 4. So all I'm left with, I have -3h over h. Yes, you are allowed to cancel the h's out and just be left with -3. Would make sense here, because this thing is a straight line. So the slope between any two random points on that line is going to be -3. That makes sense. You with me so far? Okay, now, this is on the bottom. What does this thing look like if you're going to graph it? This is a parabola. I know it's some U-shaped thing, right? So I won't be able to find the slope of the secant line between two random points. Well, it's gonna change depending on the points that I pick, right? If I pick two, like one here and one here, I'm gonna get a negative slope of some sort. But what if I had picked, I don't know, what is actually the cutest one? If I pick this one and this one, now I have a positive slope. It's going to change. So I actually did this one out, and I my answer was an answer here. Change your answer has errors, and did yours? And what you get? Yes, file check. And that makes sense because it's gonna depend on what piece that I want. I now have the formula to figure out the slope of that line where I want. I just plug in this value. So let's go to the. So this is here the problem yet. To that. Yes, is delta and next. Right? No, but it doesn't matter. You still offer everything operating the same way. So I'm going to go ahead and go to take my function. The inclusive x, go just into over inside x. So I take x is due to x, and I'm gonna pop it in right there, place that. I'm then gonna square all that and that would be this check. Does that make sense? Okay, so that's what we did over here. Me of so x squared put it in x x plus delta x and square 2. Now to do this math, I need to fill the two together. That's what we get. I can't finally turn to working. So that is this first chunk. I'm not gonna finish the formula. I'm gonna take that whole chunk and then the original function from it. So that's what I did here. So everything else. So the g of x to x to my answer. It's just right there. And I need to subtract the original function from it. So it's minus squared minus 2. And I'm gonna divide the whole thing by x. And then when you simplify, I have a positive square negative square goes away, plus 2 minus goes away. Then we'll with this kind of funky thing. What you can do, maybe if you kind of note here, I can factor out delta x in this. So take out delta x and let 2x plus x squared of the. And I cancel delta x with delta x, and that's how I end there. So now, if I wanted to go ahead and find so that secant line between these points like that, I would plug in x into x and be able to get that. Nice. So that's the difference quotient. Does that make sense? Yeah, it's weird to you. I